Hi guys, my name is Soman Kumar. Today I'll be covering chapter 9, Bacteria, Transcription and Initiation. So let's have a look. And my matrix number. Okay, let's see. The first thing I'm gonna discuss about today is transcription in bacteria. So let's have a look. The subtopic is said to be promoters initiate transcription. Okay, what is a promoter? Promoters are a sequence of DNA which proteins bind and initiate transcription of a single RNA from DNA. These promoters, they are located near transcription sites of genes. So these promoters, they are located in the upstream of the starting site in the bacteria, and this transcriptional start site is the first base used as a template for the RNA, which is denoted as positive 1, which is showed in figure 4. Okay, within the promoter, there are something called as sequence elements. These sequence elements are really crucial. It's like the elements which help in specifying the location of initiation of the site. If let's say you want to do some work, let's say you want to go and get your things from a place like let's say a postage area, you need to know the address. These sequence elements, they act as if it's an address, and they show the specific site where the transcription needs to be happened. So these are one of the examples of the sequence elements, which in E. coli, the common sequence is in the 10th region and the 35th region prime, and they are very important. So goes on the examples. So the sequence within these regions may vary slightly, but typically they have a consensus sequence of bases. Even though they may vary a bit plus or minus over there, it's always the same sequence which comes over in the sequence elements. Okay, this is one of the example of sequence elements showing a coding strand and the promoter region, which is having the sequence elements over here. And there's also an arrow showing the transcriptional starting site, which I just now stated as the prime 1 and prime 5. Okay, let's have a look. This is also one of the examples and variety of bacterial promoters. Okay, now we go on with the process, how the initiation process of transcription. Now I'm mainly going to discuss about that. So let's say binding of the RNA polymerase holoenzyme at the promoter. Okay, when this RNA polymerase holoenzyme is combined with the promoter, then only a certain processes, the initiation process goes on to undergo transcription. So the enzyme that catalyzes RNA synthesis over here is called as RNA polymerase. This RNA polymerase holoenzyme is composed of the core enzyme, which has 5 subunits, and sigma factor, which is 1 subunit of sigma. The subunits of RNA polymerase have different roles. Now let's discuss about the roles of this RNA polymerase. This RNA polymerase has the alpha subunits, which are involved in polymerase assembly and binding to the DNA form hydrogen binding with bases. And the other functions will also be that the beta subunits are involved in DNA binding and catalytic processes. The other function will also be the sigma factor recognizes the promoter. So I would like to explain a bit what I'm trying to say over here. Okay, when we see, okay, let's say the binding of the RNA polymerase to the promoter, when the promoter is the actual site, the initiation site for the transcription, you need the RNA produced. The main process of transcription is that we take a copy from the DNA and form it as an RNA. So this so-called mixture of RNA synthesis, this RNA polymerase, it's like a solution to produce an actual RNA, which is the main purpose of the transcription process. So now I've discussed the just now I have just said the importance and the roles of this RNA polymerase, which are they have the subunits to assembly the DNA forming hydrogen binding sites. Only when they assemble these hydrogen bonds and whatsoever, then only they can cut off the bonds and form new bonds to form the new ribonucleic acid form, RNA form over here. Okay, so let's go on with the further explanation. The RNA holoenzyme binds loosely to the DNA and moves along the strands until the sigma factor recognizes the 10th prime and the 35 regions of the promoter. So this is one of the process which undergoes when after I'm discussing the rules of the RNA. What I'm doing is that the RNA holoenzyme is slowly binding to the DNA. When the RNA bonds to the DNA, it specifically bonds in this specific factor, which is in the 10th prime and the 35th prime in the region of the promoter. So that only this region is it needs to be this specific. Then only we can find the actual part where we need to undergo the transcription. So the internal region of the sigma factor with the helix turn helix structure then promotes tighter binding to the DNA. So this promotes the internal region. The DNA, it's like a helix like shape, right? This helix like shape promotes a tight binding to the DNA. It binds very tightly to the DNA, and this involves the interaction with the major groove of the DNA. This process goes on with the major groove, and once bound to the close promoter complex, it unwinds the DNA beginning at the 10th region. This occurs in the TAT bases. This bases, the ATGC, right? It specifically occurs in the TAT bases at the 10th region, and this is due to the few hydrogen bonds between A and T. When the hydrogen bonds are really less between these regions, it's very simple to break the bonds and form newer bonds. And this process is outlined in the figure 7, which you can see the helix structure binding to the major groove, turning clockwise or anti-clockwise or something like that. Okay, these are the processes which I just discussed on and on. You can see in the graphic form. And thank you for the opportunity given to explain this transcription initiation process. Thank you very much.